Hi guys, welcome back. We're going to talk today addition of radical expressions and weighted averages. I'm in the third edition Algebra 1, Saxon Algebra 1. I'm on lesson 65 here and we're going to jump right into it. Now, this is what the first example looks like, but I want to just sidetrack for a second and say if we had 4x minus 5x plus 12x, all we would do here is do 4 minus 5, which would give us negative 1, plus 12 would give us 11x. Folks, when we have radicals attached to our numbers, it's the same thing. So this is just 4 root 2 minus 5. And notice we didn't do anything with the x here. We're not going to do anything with those root 2. The only time you do anything underneath the table there would be if you're multiplying. But since we're not, it's going to be negative 1 root 2. And usually we don't write it as negative 1. We just write negative root 2. Plus 12 root 2, and then negative 1 plus 12 would give me 11 root 2, and that's how you do these guys, okay? That's how we simplify adding and subtracting these guys. Now, let's talk about this one here. We have 4x plus 3y minus 6x. If I had this problem here, I would do 4x minus 6x, which would give me negative 2x plus 3y. Now, I would not be able to combine these two because they don't share the same variable. That applies for this type of a problem as well. So all we're going to be combining here is 4 and negative 6, which gives me negative 2. And again, root 3, I don't do anything with that radical, I just leave it as it is. And then bring down that other one, plus 3 root 5. That's as good as this problem gets because I cannot combine these two. Just like x and y can't be combined, root 3 and root 5 are two different variables if you want to think of it that way. Okay, so same idea here. Let's highlight or let's underline the like terms that we can deal with here. So what I can do here is negative 3 root 2 and negative 2 root 2 gives me negative 5 root 2. 5 and 8 will give me 13 root 3. And again, root 2, root 3, those are different, so I can't do anything else. That is my, my simplification, I guess you could say. I guess it's my answer, yeah. Okay, so then looking at this guy here, I can't combine any of those things. So our answer is literally 4 root 3 minus 2 root 2 plus 6 root 5. Because if you think about it like our variable method that we did here, x, y, and z, those are all different and we cannot combine those. All right, so example 5 and 6, we're going to talk about weighted averages here. And a weighted average is like if I said that your tests in this class are 80% of your grade. They might not be 80% of the total points, but they're weighted heavily so that they count more for your grade than say your homework assignments would. We're going to start with some examples that are a little bit easier than having to deal with that, just so you kind of get a feel of it, but it's just a level, the weight part is a level of importance. So for example number 5, and if you're following along, this is on page 265, it says Jim's scores were 60, 70, 80, 90. So the score, help if I could spell. So the scores were 60, 70, 80, and 90. What is the weighted average of the scores? If the tests were weighted, so the weight was 1, 2, 3, 4, and 6. So the way this applies is a test that's weighted worth 2 is going to be double the value of one of it worth 1, right? So if we wanted to do this the long way, what we would do is we would do 60. So average, remember, you add up all the numbers and divide by the number. Our normal average here, we would add up this plus this plus this plus this and divide by 4, right? In this case, though, what we're going to do is we're going to, there's basically the equivalent of 160 plus 2 70s, so 70 plus 70, and then the 80 test was weighted as a 3, so that's 80 plus 80 plus 80 plus 4. Oh, I missed one, hold on. 6, 1, 2, 4, not 3. It helps you read the problem, right? So 1, 2, 4, and 6. So that means there were 160, 2 70s, 4 80s, which means I need to add one, and then 6 90s. So plus 1, 2, 3, 4, 5, and 6. I'm going to cram those all on there. So we would add all this up and we would divide by 1, 2, 3, 4, 5, 6. Oh, I already lost track. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And we would divide by 13. That would give me my average. If we did that, we would get 1,000. On top, we would get 1060 divided by 13, which would give me 81.54. Now, it's a kind of a pain in the butt to write it out all like this every time, right? So on our next example, I'll show you, just use multiplication. It looks like a crazy formula that you have to memorize, but you really don't. It boils down to this, but then using multiplication. So for our second example, in the graduate level course Smith R was taking, each of these 3 tests were weighted 20% and the final paper was weighted 40%. Smith's scores for his 3 tests were 60, 70, and 80. His score on the final paper was 60. So I'll put that as the last one. And then the weights were, so these were his, each of the tests were weighted 20%, and this one was weighted 40%. So let's use some multiplication because that'll make it a lot easier here. Now, when we're dealing with percents, we do need to convert this into our decimals. So we have 60 times, so yeah, let's do this. So we've got 60, which would be 0.6, right? I'll put it right here. 0.6, we're gonna multiply that times 0.2 because that is our 20% here. Plus 70 times 2, just like I did up here. 60 times 1, 70 times 2, 80 times 4, right, because there's 4 of them, 90 times 6. We're doing the same thing here. So it's going to be 0.70, or just 0.7 would probably be better, times 0.2. I'm going to use parentheses here so those decimals don't get confused. Plus 0.8, because that's 80%, times 0.2. Okay, plus 0.6 times 0.4. All of that we're going to add up. Now, what we have down here is we did 20% 1, 2, 3 times. So we have to do 0.2 plus 0.2 plus 0.2, or 2 times 3, 0.2 times 3. And then we've got to do this 1 time. Since we did it 1 time, we're going to do plus 4. Okay, so if we do the math on that, we would end up with 0.66, which would give us 66%. 66%. So those are how you do weighted averages. All right, guys, here are your practice problems. They are on page 266. Go ahead and pause the video, do those, come on back, make sure that those are showing up on your homework, please, and then come on back. All right, guys, for our first one here, we have this and this. Those are the two that we can combine. 3 plus 5, that's going to give me 8 root 3. And then this guy, I can't really do anything with that, so I'm just going to bring it down. Minus 2 root 2, because 3 and 2 are different. 7, 7, 7. That means we can combine all of these guys. So we have 6, 7, 8. So 18 root 7 minus 20 root 7 will give me negative 2 root 7. All right, so for this guy, oh, this one's a little tricky because in front of here, there's actually a 1, okay? It's just like if we had an x, you don't put the 1 in front of that variable. And then this is a root 3, so we'll leave that alone. So 1 plus 3 is 4, minus 4 is 0, 0 root 2, plus 6 root 3. But normally we don't write 0 root 2 because 0 times root 2 is just going to be 0. So we're going to get rid of that. So our answer is just 6 root 3. All right, so on this guy right here, we've got a weighted average of, here's our scores and here is our weight. So we have 70 times 1, 80 times 5, 100 times 7. over 1 plus 5 plus 7. All right, so then we've got, oh, and I meant to, sorry, I just realized I forgot to put my plus sign in here. We're not gonna multiply those all together. So we've got 700 here, and then 80 times 5 would be 40 with a 0 for that guy. And then 70 times is so 70, so we have 700 plus 400 plus 70. I don't know why I had to use a calculator to do that. I have no idea why. It's probably because it's late. Equals 1170 divided by 7 plus 5 is 12, 13 equals 90. So the weighted average of this would be 90. Okay, guys, if you have any questions, let me know. Otherwise, great work, and I'll see you in class.